Hello, and today's purpose of the day is I can complete the square to solve quadratics. In perfect square trinomials in which the leading coefficient is 1, there is a special relationship between the coefficient of the x term and the constant term. We are going to look at, if we are given a perfect square trinomial, how we can get that into its factored form very quickly. This will help us today when we want to complete the square to solve quadratics. Steps to completing the square. To complete the square for any quadratic expression of the form x squared plus bx, we need to follow the steps below. Step 1. We are going to find 1/2 of b, the coefficient of x. Step 2. Square the result in step 1. Step 3. Add the result of step 2 to x squared plus bx. This will allow us to complete the square and allow us to have a perfect square trinomial, which then we can quickly factor to solve the quadratic equation. Let's look at the example below. What is the value of c so that the expression is a perfect square trinomial? So our first goal right now, before we begin to solve quadratic equations, is let's just work on getting perfect square trinomials. We've already learned about perfect square trinomials from previous chapters, but let's remind ourselves what they are. A perfect square trinomial is a trinomial that we can easily take the square root of our first term and the square root of our last term and times 2 or -2 to give us the middle term. So let's look at the question below. What is the value of c so that the expression is a perfect square trinomial? To figure out c quickly here, we can, if we follow the steps from right above, take this, find 1/2 of b and then square it. So half of b is -5. In this case, half of -10, so -10 divided by 2 is -5. So what's half of b? Here it's -5, and then we want to square that, and that will allow us to find c, and -5 squared is 25, so x squared minus 10x plus 25 is a perfect square trinomial. Let's look at the second example. X squared plus 8x plus c. Let's figure out what c should be. So to quickly find that, let's take half of b. Again, b is 8 here, so 8 divided by 2 would be 4, but then we got to square that, so that would be 16. So x squared plus 8x plus 16 is a perfect square trinomial. Again, this is just one basic step in our sequence of steps that we're going to have to do on the next slide to complete the square. We could then easily factor these perfect square trinomials if we wanted to. We're not going to do that right now. We're just going to figure out what c should be so that we have a perfect square trinomial. Okay, here are the complete steps to solve by completing the square. Step 1. If a times x squared, then we need to divide both sides by a. So if we have anything in front of x squared that's something other than a 1, we'll have to divide by whatever that coefficient is. The main idea is that the leading coefficient must be 1. Step 2, isolate the x squared and bx terms. Step 3, add c to both sides of the equation so that on our left-hand side, x squared plus bx plus c is a perfect square. The reason we are going to do that is because then we can easily factor that, and that will make this equation solvable. Step 4 is to factor that perfect square trinomial. And step 5, solve using the square root property, which we have already learned about. Let's give 2 examples a try. Solve x squared minus 6x plus 12 equals 18. So again, step 1 says if we have a 1 in front of x squared, we need to divide by whatever that is. So the coefficient in front of x squared is 1. In this case, it is 1, so we don't need to worry about step 1. Step 2, isolate the x squared and bx terms. So what I'm going to do is move the 12 to the other side. So I'm going to subtract 12 here, so I can isolate my x squared and x term. So x squared minus 6x equals 18 minus 12 is 6. Okay, now according to step 3, I need to add c to both sides of the equation so that I can get a perfect square trinomial. So again, if I add c to one side of the equation, here I'll underline it in red, I have to add it to the other side. Okay, now let's figure out what c should be so that we have a perfect square trinomial. This was that exercise that we did on the last slide, and how we figured out c quickly was we figured out half of b, and here b is -6, so -6 divided by 2, and then we squared it. So -6 divided by 2 is -3. That squared is 9. So a perfect square trinomial on this left-hand side would be x squared minus 6x plus 9 equals 6 plus 9. And now let's go ahead and let's factor the left-hand side here and add 6 plus 9 on the other side. So I'm going to do 2 steps in one. So to factor this perfect square trinomial, okay, square root of my first term, x squared, is x. Square root of my last term, 9, is 3. And my sign in the middle should be the sign that is of my middle term. So x minus 3, the quantity squared, equals 15. Now here comes that square root property, because again, I have something being squared on the left-hand side. And how do you undo something that's being squared? Well, you take the square root. So here I'm going to take the square root of one side, and when I do that, I have to also square the other side. So when I square something and take its square root, again, those are inverse operations, so I'm left with just x minus 3 equals plus or minus square root 15. Now, why do I have plus or minus? Again, because we know that we could have a positive answer and a negative answer, because two negatives, multiply together equal a positive, so that's why we have two answers. And so my answer here in radical form, well, I'm almost completed with this problem. I have to isolate x, so I would add 3 to both sides. So x equals 3 plus or minus square root 15. That would be in radical form. And if we wanted to go ahead and figure out the actual answer here, I could then plug this into my calculator and round to the nearest tenth. And when I do that, I will take 3 plus the square root of 15 and 3 minus the square root of 15, and I get 6.9, and I get negative 0.9 for my two solutions. So again, this would be rounded to the nearest tenth, and then this one below here, that would be in radical form. Okay, let's take a look at our second example. X squared minus 8x equals negative 9. So step one, again, we're looking for if there's a coefficient in front of x squared that's not 1. Today we are only looking at examples that have a coefficient of 1 in front of x squared, so we don't have to worry about that step. Then we want to isolate our x squared and bx terms, and it is already isolated because our negative 9 is on the other side. So I'm just going to add c to both sides of the equation so that I can have a perfect square trinomial. Again, if I add c to one side, I have to add it to the other. And then how do I figure out c again to be a perfect square trinomial? I take half of b and I square it. So negative 8 divided by 2 squared is negative 4 squared, which is 16. So a perfect square trinomial on this left-hand side would be x squared minus 8x plus 16 equals negative 9 plus 16. And now let's go ahead and add the right-hand side and factor the left-hand side at the same time. So if I factor this perfect square trinomial, I take the square root of x squared and get x, square root of 16 and get 4, and then my sign in the middle should be the sign of my middle term, equals, and negative 9 plus 16 is 7. So this is good because I have a binomial being squared equal to a number, and we know how to solve equations like this by using the square root property. So I take the square root of both sides, and I'm left with just x minus 4 equals plus or minus square root 7. Last move to isolate my variable is add 4. So I get x equals 4 plus or minus square root 7. Again, this would be one version of my answer in radical form. And then if I wanted to go ahead and round this answer to the nearest tenth, I would type in my calculator 4 plus the square root 7 and 4 minus the square root 7. So I would get x equals 6.6 and 1.4 for my two solutions. Thanks for listening, and please check Google Classroom for your assignment. Have a great day.